Hello, geometry folks. So today we are going to be learning about the converse. So what that means is that instead of solving for a variable like we've been doing, given that lines are parallel, we're going to use algebra to determine if two lines that are cut by a transversal are parallel. So all you're going to need today are your notes. Our learning target for today is to be able to use information in a diagram to determine if the lines are parallel. And in this particular diagram, we know that these lines are parallel given that this notation tells us that. So when we see this double arrow right here on both lines, we know that it's parallel. So by this diagram, it's pretty easy, but we'll get into more complicated stuff in just a second. Let's consider where we've been. These last couple days, we've been talking about if two lines are parallel, then alternate interior angles are congruent. So that's been our statement. We've said if two lines are parallel, then alternate interior angles are congruent. And we also talked about alternate exterior angles being congruent if two lines are parallel. And we also talked about corresponding angles being congruent, and of course, same side or consecutive interior angles being supplementary. So that's what we've been doing. We've had this statement, if two lines are parallel, then some sort of angles follow with congruency. Today, we're going to be doing the opposite. So we just reverse the order and we call that the converse. So now we're saying if alternate interior angles are congruent, then two lines are parallel, the lines that are being cut by the transversal. So we're going to be looking at the exact opposite in our notes today. So just make sure that you note that this direction of writing it, our if-then statement in this direction, is known as the converse. So the four theorems that we worked with in our green foldable are what are written here. If two lines are parallel, then corresponding angles are congruent. If two lines are parallel, then alternate interior angles are congruent. If two lines are parallel, then alternate exterior angles are congruent. And lastly, if two lines are parallel, then consecutive interior angles or same side interior angles are supplementary. So the converse of all these statements is what this arrow is saying. Just like I said on the last slide, we're going to switch the order. So this is where we're going to have to get that into our notes. So I would get these statements written into your notes. So these are the converse statements to all the four theorems from our green foldable. So the first one is saying if corresponding angles are congruent, then the lines are parallel. The second statement is if alternate interior angles are congruent, then the lines are parallel. And I'm sure you can guess what the third one is. If alternate exterior angles are congruent, then the lines are parallel. And lastly, if same side or consecutive interior angles are supplementary, then the lines are parallel. So make sure you get these four converse statements written down in your notes. Okay, so we're going to go through some examples and feel free to write as many or any or all of them in your notes. So we're asking, are the lines M and N parallel? And we need an explanation. So we have in our diagram these little hash marks on the angles. So this red hash mark is saying that this angle right here is congruent to this angle, right? And we know that these hash marks, or this angle and this angle, are alternate interior angles, right? They both lie in the interior of those two lines and they're on opposite sides, so they're alternate interior. So do we know that they're parallel? Yes, we do. We do know that they're parallel because of that alternate interior angle congruence. So if we wanted to write M as parallel to N, remember that notation would be M parallel to N. So line M is parallel to line N. That's how we would write that. You don't have to. In this case, our question was yes or no. So yes, it is because of alternate interior angles. So if we look at the next example, we have hash marks again showing that this angle is congruent to this angle. And those two red angles are on the opposite sides of the transversal, and they both lie in the exterior part of the two lines. So that means that they are alternate exterior angles, and we also know that they're congruent. So do we know that these two lines, M and N, are parallel? Yes, we do. Yes, because of alternate exterior angles and their congruency. So if we wanted to write, again, M parallel to N, it'd be line M is parallel to line N. So that parallel symbol is just like a skinny 11 or two parallel line segments, if you will. So in our next example here, we have the lines M and N again, and we have it being cut by a transversal. We have this red angle and this red angle, and we know that they're congruent given that the slash marks are shown. And we need to think to ourselves, are these two angles right here form a relationship that we've talked about? So are they corresponding? Are they same side? Are they alternate interior? Are they alternate exterior? And in fact, they are corresponding angles. So we do know that these two lines are parallel because of corresponding angle congruency, or because corresponding angles are congruent. So let's take a look at another example. Now we have the transversal cutting the two lines vertically rather than horizontally, so our picture is a little different, but we know that this angle and this angle are congruent. What kind of angle pair does that form? Does it form alternate interior, exterior, same side, or corresponding? No, these are vertical angles. Well, vertical angles, we haven't been given any theorems about vertical angles other than they're always congruent. So based on just this vertical angle relationship on this one line and this one intersection, we cannot say that these lines are parallel. We don't know. There is not enough information on just vertical angles. We only know that those things are congruent, but we have no idea about the lines if they're parallel or not. So let's take a look at an example with some actual numbers in it rather than just some congruent symbols. So we know that we have the angle measure of 143 and the angle measure of 37 for this angle and this angle. These two angles are same side interior or consecutive interior, right? So if they add up to 180 degrees, then we should know that our lines A and B are parallel. So let's see if they add up to 180. 143 plus 37 is a 180. Yes, it is. So these lines are in fact parallel because the same side interior angles are supplementary. So if we look at another example here, we have the angle measuring 114 degrees, this angle right here, and we have 66 degrees for this angle and 48 for this angle. We know that the 114 degrees of this angle and this entire angle, this big angle with these two summed together, these two angles summed together, that these two angles, this one here and this one here, are alternate exterior, which means that they should be congruent. So let's check and add 66 plus 48 to see if it is in fact 114. 6 plus 8 is 14, 6 plus 1 is 7, plus another 4 is 11. So indeed they are both equal to 114 degrees. So that means that our lines are parallel, A and B are parallel because of alternate exterior angles being congruent. So we're down to our last two examples here. So we have our image, we have line A and line B. So I know we have a little triangle here, which can be a little confusing, but let's focus on this line if this was the transversal that's cutting lines A and B. So if that's the case, we have this angle, which is 60 degrees, and we have this entire angle, which is 60 plus 60. Well, 60 plus 60 is 120. Well, and this entire angle plus this entire angle, those two angles then are same side interior, right? They're on the inside of A and B cut by the transversal. So is 120 plus 60 180? Yes, it is. So we have same side interior or consecutive interior angles equal to 180. So then because of that, if we have that happening, then our lines are in fact parallel. So yes, our lines are parallel because of same side interior angles being supplementary or consecutive angles being supplementary. So let's look at the last example. We have this angle here that measures 106 degrees. And then we know that this entire angle is the alternate exterior pair, right, from this angle. So we just need to add 54 and 49 and see if it equals out to 106. Well, 4 plus 9 is 13, and 5 plus 1 plus 4 is 10. So, is 103 equal to 106? No, it's not. So because they are not congruent, then we can say that these lines A and B are not parallel. These lines are not parallel because the alternate exterior angles are not congruent. So again, if we wanted to write this in notation, we would have A not parallel to B, and that's how we would write it. You would write A parallel to B and then cross it off with a slash. So it's like 11 with a slash through it. So this is how we would say in notation, A is not parallel to B. So line A is not parallel to line B. So you guys, that's all I have for you in this video. And just get used to justifying every teeny tiny step, even if it seems super trivial, because this whole entire exercise with our green foldable and the Converse is to get you prepared for proofs. And we will be doing that later in the year. And so I'm just trying to introduce some steps so that proofs aren't such a shock to you. So just get used to justifying all of your simple geometry steps as to why you know certain things are congruent or parallel or stuff like that. So that's all I have for you guys. Peace out.